Now let's explore some map operations. We can use lists as a starting point and see how maps are similar to but different from lists. For instance, while the elements of a list are accessed by position or index number, elements of a map are accessed by a key, which could be any object type, including numbers and text. For example, consider the following list L. We can make claims such as the element at index 2 of L is equal to 43. Now consider the following map M. In lists, we index by position, but in maps, we can index by the key. For example, the value at key London of M is equal to 10. We surround London with double quotes since London is text rather than a variable. We can update maps by specifying a value for some key. If an entry with the key already exists in the map, then the corresponding value is updated. If not, a new entry is added with the key and value. For example, suppose we have this map and we store 35 at key Tokyo. Here's the new map. As we can see, the second row was updated. Next, suppose we store 8 at key Los Angeles. Then the map is now this one. As we can see, a new row or entry was added to the map. We can also delete entries from a map by specifying a key. For example, after we remove the entry with key Chicago, this is the new map. Notice Chicago is now missing from this table. The length of a map is simply the number of entries in the map. For example, the map above contains 3 entries, so the length is 3. In Logic Walk, we're going to represent a map as a stack of entries. Here's an example entry with key Chicago and value 4. And here is an example map. This representation is substantially different from the popular hash map hash table implementations. But the map interface, which is how we interact with a map, is the same. So you will be able to comfortably use both the Logic Walk map and the hash map after this chapter. Next, let's utilize this representation to precisely describe the map operations.